So now you have understood what is hazard, what is risk, how to identify hazards or determine hazards, how to assess risk. And now we are going to talk about determining controls. Determining controls follow a certain sequence, expected sequence, which is called hierarchy of control. In other words, certain activities, certain control should come in the first order, then next type of control, then next type. So it should move in a sequence of priority which will be most effective. So while we talk about determining control, we talk about a hierarchy of controls. Let's see how hierarchy of controls have been organized and how logical they are. The first is elimination of the hazards. Eliminate the hazards, remove the hazards. If the hazard is not there, this means the chance of an occurrence of an incident is eliminated. For example, you have got a high chance of a fall from a slippery floor or which is an inclined floor, which is raining and slippery, and that doesn't have a handrail. So if you approach there, you are almost certain that you are going to have a fall. And if it is height, it could be very, very dangerous. So if you avoid going there, you are eliminating the hazard. So you have got an unsafe condition already there. And unsafe act would be to go there at that point of time. So if you avoid that, the hazard has been removed. The chance of an accident is eliminated. So eliminate the hazard. This is the first in the hierarchy. Next is substitution. Here, I would like to give a good example of Bhopal gas tragedy. You all are familiar, most of you might have heard of Bhopal gas tragedy of Union Carbide that happened in 1984 in Bhopal in India. Methyl isocyanate leaked from a tank, killing more than 10,000 people, and several thousands were impacted and affected. Even now, children are born with deficiencies, physical deficiencies. It is considered to be one of the worst chemical disaster in the world. Now, what happens? They have got phosgene gas and methyl isocyanate that reacts together to develop the product called carburyl, which is sort of a pesticide. Both phosgene and methyl isocyanate are very lethal, toxic, and killer gases. And they are stored in greater capacity means there is a greater chance of accident, which really happened. Now, Bayer, on the other hand, have got an alternate technology, a better technology, by which the methyl isocyanate is converted before mixing with phosgene. Therefore, they reduce the chance of this fatal gas storage, killer gas storage in large quantity. So they have evolved a better process, chemical reaction, by which they reduce the hazard to a great level of acceptable risk, by which they are still continuing in the world producing the similar product. So substitution is the best way when elimination is not possible. Substitution is doing it with a safer technology, with a better technology, or with a better control. Next comes engineering control. For example, you have a hazard, you have identified the hazard. Neither you can eliminate accessing there, you have to go there, people have to go there, and there is no way to substitute this work. So the alternate action next would be engineering control. Engineering controls are basically safer design by some engineering process controls. For example, putting a handrail. is a kind of engineering control that will that will ensure the persons do not fall out of the height. And recently it happened in Kerala. One of the lady officer, she is a minister or a secretary, had fallen from height and had fatal injuries because she was sitting on a very high elevated platform, and there was just a black ribbon or some kind of a ribbon without having any barricade or any handrail. And while shaking hands, she has fallen from almost 15-20 feet height. That was quite a dangerous thing to happen. So clearly what was missing is that could have been eliminated. First of all, that could have been substituted with some other sitting arrangement, or at least brought in a handrail that could have prevented such kind of an incident to happen. So if you are having some activities like this, engineering control is always an engineering provision to bring the risk under acceptable level of control. For example, you have got moving parts. For example, you have got moving parts. You have got a fan or a rotor blades, rotating in a high speed. And if it is open, anybody can be sucked in and the cloth can get entangled, and that could cause a fatal injury. For example, there is a heavy duty rolling operation, hot rolling operation of some bars and flat bars going. So if you put some kind of cage around that, this is going to be within the cage in case something goes wrong, not piercing the people who might be working adjacent to that place. So things like that. Any control that is engineering, for example, putting a cover of the rotating components, putting a cover on the chains and the sprockets, these kind of controls will bring in engineering control. Those engineering controls are very effective way to prevent or reduce the likelihood of a risk to happen. So we talked about elimination, if possible, substitution, and then engineering control. Then comes signage, warning, and administrative control. Administrative control is when you have got some procedural requirements that has to comply with. For example, permit to work system. It's a very common practice in oil and gas to have permit to work system. So if you are going to work in a refinery, for example, or for example, a gathering center, a booster station, or a chemical plant, or a high risk facility, you are required to get a permit to work. That would make sure someone responsible is requesting for a permit, and these are the kind of work they are going to do. And the responsible authorities within the plant will look at these are the activities, these are the kind of hazards involved, and whether they have identified those hazards, and do they have controls and train people to do the work safely. And if something goes wrong, to establish a communication and prevent the incident or accident from happening. So these kind of control, signage, for example, or warning, don't go there. Or for example, scaffolding, there's a green tag. This means it is good to work with, it's safe to work. Or red tag means this is not safe for working. Those kind of things, or putting a barricade around the place are kind of controls to make sure the place and work remain safe. And the last one is personal protective equipment. Personal protective equipment is the last line of defense where you have got headgear, hand gear, or protect your body parts so that if something goes wrong, you've got the last line of defense. For example, while driving, you are using helmet. You are putting knee guard and ankle guard and elbow guards and stuff like that. And also hand gloves so that in case of an accidental skid and fall, your body is protected. But those are the last line of defense. You cannot say that there is a hazard, just put your helmet and go and work. Or there is a possibility of toxic gas release, just put a mask and go and work there. Your attention should be first to avoid going there, or if it is possible, and if you have to go there, look at the engineering control. Maybe engineering control in this case could be giving a noise or a gas detection system, which will alert the person that here is a danger of H2S and there is an alarm going on. So please don't go there. And that's the kind of engineering control that can be brought. Now, when we talk about the controls, that does not mean that has to follow the same sequence only. This is the ideal sequence. Maybe there are more than one or several control, or all of them as applicable can be brought. Maybe elimination is not an option, so substitution may not be an option. So if it is, then substitute, at the same time bring in engineering control, also provide signage and administrative control, and also provide personal protective equipment. It is not that only one has to be there or needs to be there, or only one is adequate. There may be more than one or combination of all of them. I think I've given adequate example for you to understand the kind of control that is required. So if you look at, first of all, eliminate, substitute, bring in engineering control, administrative control, which includes signage and posters, warnings, and so on. And the last line of defense is personal protective equipment. Personal protective equipment is to protect the body damage, bodily injuries, finger, toe protection. For example, if you are taking a safety shoe or headgear or a safety helmet, these are all kind of personal protective equipment. For example, working at height, putting a lanyard and safety harness is one of the personal protective equipment that you can think of. Thank you.